Okay, we're comparing the price of 2 bowling alleys. Val's planning a bowling birthday party, including herself. There will be no more than 10 guests, so we have 10 people total. Val wonders which bowling alley offers the less expensive party. Complete the tables for Leonard's Lanes and Southside Bowl on the same grid. Graph the ordered pairs in each table. Use a different color for each of the values in each table. Which bowling alley would be less expensive? Explain how you know. So our value is going to be $10 per person. Wait, let's see, $20, $25 plus, it's going to be $10 plus X. Let me clear that off. It's so hard writing without this. So the cost is $25 is a fixed cost, and then we're going to add $10 times the number of party people. So for number one, we have 25 for one guest. For one guest, we're going to have $25 plus 10 times 1. That's where we get the $35. For 2 guests, we're going to have $25 plus 10 times 2. So 25 plus 20 is 45. So for 3 guests, we'll have $25 plus 10 times 3. So we would get $55. And you can see it's increasing by 10. 55, 65, 75, 85, 95, 105, 115, and 125. For Southside Bowling, it's $15 a person, period. That's it. So we're counting by 15s here. 15, 30, 45, 60, 75, 90, 105, 135, and 150. So at 10 people, we wind up with 150 here. 10 people, it's 125 here. So we can see that Leonard's Lanes is cheaper by filling out that chart. And if you graph it, if you make a coordinate grid and graph the values, you've got a double line graph. So when you have one guest, I'll put the guests down here and the cost over here. I'm not going to make the whole graph, but starting at 0, when you have one guest at the one bowling alley, it's, if we count by 5, 10, 15, 20, 25, 30, 35, 40. I don't know what you would count by here on your intervals. I probably, if you actually had graph paper in front of you, let me see if this will work. If I put the graph paper in front of me and I wanted to do this, I would, get rid of that. Clear frame. I would take my pen and decide where I want I would be using a ruler for this, not my wiggly finger. Number of people, it only goes up to 10. So I could make that a 5, that a 10. Let's see, 2, 4, 6. Once again, I don't like that either. I don't know how you guys do this without a stylus. Okay, here we go. Not a straight line at all. Okay, so if I count by 2s, let's see, that's 1 person, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this line, I'm try to stay on the line here, like I did not on my x-axis, which goes on forever. For my y-axis, my values go all the way up to 150. So I don't know. What do I want to count on that? Let's see. How about if I count by 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50. So 0, 10, 20, 30, 40, 50. Very messy looking, I know. And this will be our cost, my labels. And my chart, I could label it comparing the bowling alleys, and these are a number of people. So I have one person at $35. Oh my gosh, 10, 20, 35. Come on, let's go there. And my next one is two people at 45. Terrible. And three people at 55. Gosh, these are terrible circles here. It won't let me just make a little blob. And four people at 65, 50, 65. So we're going to get, our graph is going to go, and this is just terrible. So technically, we're going to want one, as I graph my points, this one graph will be, you can call it, the first one would be the south side. No, the first one is Leonard's. And you just keep graphing. And then the other one will be south side starts higher, but it's going to graph. In the end, it'll graph lower. So that's how we would do our graph there. I know, a lot of work, perseverance. And let's see, we got next one. Making sense of a problem. Perseverance, working hard to finish it up. On Aiden's farm, there's 12 acres of soybeans and 8 acres of corn. Aiden plans to replace the other crops with more acres of soybeans and corn. Will his farm ever have the same number of acres of corn and soybeans? Explain. So as you figure out the chart, you're going to want to know, is there a time when they'll have the same value? And there is. It's in year 4 that they will actually hit the same point on the chart. So at year 4, they'll have 24 acres of each chart. And you can see it in the table. You can also see it when you plot it. You'll see that the points will be at the same spot. Mindy has already saved $20 and plans to save $8 each month. Georgette has no money saved, but plans to save $5 each month. Will the girls ever have the same amount of money? So on this one, you're going to fill out your chart and figure out your rule. So if we're starting at 20 and adding $8 a month, so her rule is add 8. So rule, you can say Mindy is add 8. Or actually let's get that a little bit better. Mindy equals, she starts at 20 and adds 8. And Georgette is starting at 0 and adding 5. So that would be their rule. So as you fill out the chart, let's see, 4, 5, 6. She'll have 52, 60, and 68. And if Georgette starts at 0, we're just going to count 5, 10, 15, 20, 25, 30, and so on. When you graph it, thank goodness on this one they give you a little graph. You're going to graph the information. You're going to see the two lines will never meet. So they will never have the same amount of money saved. And you can graph that. So number of months in month 1, I'll say make Mindy red. In month 1, she has, this is really, okay, oh, that worked. 28, 2, she had 36, 3, she had 44, 4, she had 52. So you're going to see this one goes up that way. And then Georgette, 0, 5, 10, 15, 20, 25, 30, 35, and so on. So you're going to see they will never cross over. So they will never have the same amount of money. And that's it.